Now, if we start to think about individuals with spinal cord lesions, so this is individuals who've got damage or had damage to the spinal column. So what we're doing is we're abbreviating it here, spinal cord injury. It results in either, and this is important, complete or incomplete transection of the spinal cord. So that is either complete breakage of the cord or partial breakage, in other words, damage to the cord. So what we understand is, in general, the higher the level of the spinal cord lesion, the greater the loss of function. And I'll show you this in a moment. That is going from what are in essence cervical, which are fundamentally the top part of the spine, which is C1 to C8. So this is all related to the vertical stacks. And then you go into the thoracic region, and then you go into the lumbar region. And the further you come down that spine, wherever you get the transection, fundamentally as you come further down, you go from cervical to thoracic to lumbar, the loss of function reduces. When we think about the cervical region, so that is right at the top part of the spine, so that is, if you think about the top 8 vertebrae, that is where we get the conditions which are tetraplegia and quadriplegia. And within both of these, the function of the upper limb and peak heart rate, amongst other systems, are affected. So you lose, with both tetraplegia and quadriplegia, you lose not only lower body function, which is what we think with spinal cord lesions, but you lose upper body function as well. And the higher we move up that spinal column, it also can have ramifications on things like respiration. So if we have a very high spinal cord lesion, so in the realms of C1 to say C3, you're likely to lose autonomic control of respiration. So, and these are affected because fundamentally in that area, the spinal cord, you've got factors associated with what's called the brachial plexus, and it's associated with things like motor control and has that ramification in terms of upper limb. But also in there, you've got the start of the spinal network that's associated with things like respiration, with regulation of heart rate. If, on the other hand, we get an injury in the thoracic region, so we're now talking kind of mid-spinal column, or the lumbar region, which is the lower part of the column, that is where we get paraplegia. So you may have upper limb function, and generally if it's lumbar, you will absolutely have upper limb function, but lose lower limb function. But you then get the varying degrees, as we were kind of suggesting with the cervical outcome, of back, abdominal or lower limb function. It just absolutely depends on where that transection of the column has occurred. So if we look at this schematic here, you can kind of see what is going on. So you can see that what we're dealing with, it's not the vertebrae themselves, of course, it's what's going on in terms of in between those vertebrae, which is where the damage is occurring. So the cervical region, which is the upper part of the spine, which runs from C1 to C8. So if you've got a damage at C1 to C4, then you are going to be almost certainly classed probably tetraplegic. You've lost control of breathing, and you've got almost no head and neck movement at all. So it's very, very significant. An example of somebody like that, maybe you may remember Christopher Reeve, who originally played Superman. He had a horse riding accident, and he lost pretty much, well, all movement, and so he became tetraplegic. As we move further down the cervical column, we move down from C4 to T1. So T1 is the start of thoracic. You've got diminished. You've got poor. You've got heart rate control, but it's diminished heart rate control. There is an impairment on upper limb movement. It's not as severe as it is in C1 to C4, but there may be some elbow and wrist and even kind of finger control. It just depends on the severity. So the further we go up, we get down to the point where we're fundamentally just down to finger control. If we're kind of in this neck of the woods here, as we move further down here, we actually gain some of those additional bimotor abilities. As we go into the thoracic region, which runs from T1 to T12, well, it has an impact on things like trunk control. There's a significant impairment on thermoregulation. And of course, not surprisingly, because of the region, it has an impact on the abdominal muscles. So there's actually quite a lot of postural instability within this grouping. And then in the lumbar region here, then of course lower limb impairment, and it's impairment initially, across the hip, leg, and the foot. There may be some movement, But again, it depends upon where we are in the lesion. And of course, as the further we go up, the more the loss of that lower limb movement becomes, and the less and less as we go further up, the upper body movement is as well. So this is taken from a paper from Todd Astorino, based out in the USA, and Todd writes this really important statement for us, which is this. In persons with a spinal cord injury, and this is a very broad characterization that Todd has used here, there is impaired neural function below the level of the injury. So fundamentally, if I have an injury at C4, then it's everything below C4 where fundamentally the function is impaired. So it'd be everything above C4 where I've still got the functioning. And that then alters things like heart rate, it alters blood pressure, and it also, interestingly, alters catecholamine release, things like adrenaline and noradrenaline. Now, we can see this on this kind of simplified schematic here. So what you've got here is you've got wheeling racing performance. This is a kind of our metric. So on our y-axis, this is our metric of performance. So fundamentally, what we know is wheeling performance in a wheelchair kind of activity is a function, really, isn't it, of upper body strength. So what you start to see is if you look here, so here you've got somebody who's got a C6 lesion. Okay, they've got a C6 lesion, but they've got arm strength. Okay, so actually our time, our wheeling racing performance time is slower. They've got limited arm strength than somebody who has got fuller arm strength with a C6. So it just depends on the kind of the impact that it's had. You compare that though to somebody with a T2, so they are borderline, but actually because the impact is in the thoracic region rather than the cervical region, so it's not a big difference where we are. Remember, it goes C1 to C8, and then we go into the thoracic region. Actually, their wheeling performance is much better. They are functionally more capable. But it's interesting if you take somebody down here, which is what they've called a C6 as well. Again, because they have lost arm strength, it's also potentially having this impact on pelvic strength. But there may be greater pelvic strength in this kind of grouping than this grouping. And this is the complexity of what is going on, which is there isn't a kind of a one-size-fits-all characterization of this. You can have a spinal cord lesion at, say, C6, and you'll have two different individuals who have slightly different physiological responses to that. The primary responses will be the impairment in upper body strength, but the other factors that go with it, in terms of pelvic strength, for example, will be very much dependent upon the nature of that injury that they have suffered. So if we then take this a stage further, and we look at this data set here. So what we've got is we've got wheelchair classifications. So in Paralympic sports, T is for track. So that is the way they define it in track racing. And then you go from T51 to T54. It's a particular kind of group of Paralympic athletes. There are other wheelchair groupings that we could look at, but this is quite a neat way of exploring this. So without us really understanding what is going on, without us really knowing the nuances of the physiology here, we can quite clearly understand that a T51 is more physically impaired than a T54. They therefore have probably got a higher spinal cord lesion in a T51 compared to a T54. How do we know that? Follow the times. So if you take this data set here, this is our 800 meter times from the T51 to 54 athletes. And what you can see is in a T51, they're averaging, it's still, compared to an able-bodied runner, it's still reasonably quite good, 160 seconds. By the time we get to a T54, they're well under 100 seconds. They're actually close to about 90 seconds, 1 minute 30 for an 800 meters. And you see the same at 400, 200 and 100 meters. And it's interesting that as the distance increases, you start to see a magnification of the impact of the spinal cord lesion on performance. There's very little effect when we go from across 100 meters from T51 to 54. It goes from about 20, well, it's difficult to know, but let's call that 22 seconds to probably in the region here of about 18 seconds. As an example, it's about a 4-second difference, approximately. Or if we take, say, our 200 metres, which goes from 40 to 20 seconds, there's a 20-second difference there. Still quite large, but compare that to what you're seeing here, which is well over a 65, nearly 70-second difference. And this really lends itself to the remainder of the journey within this presentation, which is, why is it we're seeing such a large magnification over at 800 metres here, which we're not seeing at these shorter sprint distances? And how does the spinal cord lesion seem to create that magnified effect?